Thank you. It's a great honor to be here. Thanks for the invitation. Today I'm representing Viasat, but it feels great to come back to what is my academic home. I was an alumni at UCSD. I'm actually a spouse of an alumni as well. I was a volunteer in this building before the building had a name, and when Professor Ramesh Rao, had his office in a trailer on that side, I believe. So it's great to be back. It's an honor, and I hope you'll find some of this interesting. As I was listening to the previous panel and I was seated over there, about 15 minutes ago, my phone suddenly blew up with messages. Probably some of you know why. And I was just thinking, what we do, I could have named this talk, enabling your phone to blow up anywhere in the world, right? I mean, that's the goal of NTN, a non-terrestrial network. And I should caveat that these views, obviously 6G is still very early. We're barely starting with 5G. And these are very early views, but this is where we see the satellite ecosystem going. So let me figure this out. Okay. So, I start with this quote, which, is pretty prevalent here at Viasat, which is that any sufficiently advanced technology is indistinguishable from magic. And if you think about what we do in the cellular world, and now with the integration with satellites and the ability to communicate anywhere from everywhere, with, extremely small, relatively cheap devices is frankly, in my view, almost magical. And we should, as we look forward, we should also look back to see how far we have come. And for a lot of you, some of you have played very integral roles in that. I think we should, take a moment to celebrate our magic that we have created, enabling people all around the world to communicate and, allowing them to get important information. So we live in a world where connectivity is no longer a luxury. It's a primary need. And of course, during the COVID pandemic, this was even more, clear to us, as everything from education to health was done through a connected network. And it's one of the cases where, as tragic as COVID was, it highlighted many different ways of being connected and enabling efficient connectivity. So as far as satellites are concerned, and as far as the ecosystem is concerned, in 5G, we went non-terrestrial, right? And so there's NB-IoT and 5G NR, new radio. And Viasat actually has an NB-IoT network up and running today. So where are we today? So let's first take a step back and see where we are today before we look forward to where we are headed. So today, we have very high throughput satellites. We have a terabit per second satellite. Viasat-3 was launched. Some of you might have seen the press releases that in space, it suffered a launch anomaly, or rather an anomaly in space. And despite that anomaly, which was a very significant anomaly, we have been demonstrating and doing tests today where we get 240 megabits per second on the downlink, tens of megabits on the uplink. And there is a video, which I won't subject you to, but you can Google and go online and look at it. And these are actual tests of planes flying around over the United States, over various areas. And we are consistently getting upwards of 200 megabits per second. And this is from a satellite which admittedly has had a fairly significant anomaly. We have other satellites of that class. And again, a shout out to the competition. I have to say, we are not unique in this regard, but the ability to provide hundreds of megabits per second to a terminal from a satellite is now real. It's happening. It's right here. Okay. The other thing that has happened is we have now a global, resilient, integrated network. And what do I mean by integrated? Well, first is integration with orbits. So there's multi-orbit. So there's geosynchronous orbits, low Earth orbits, medium HEOs, which are highly elliptical orbits, which are useful for covering the poles, and also terrestrial networks. These are actually coming together. and in an unified network, right? So these are some screenshots from press releases that we have where, over the Arctic, we can now provide high-speed internet. Those of you who've traveled internationally on planes, you can get internet. And depending on which airlines you're on, if you're on Delta, JetBlue, you can do streaming video to your device on a plane at 35,000 feet. We are going for multi-orbit in the maritime space. This is a fairly recent press release where we are integrating LEOs and from different frequency bands as well. So there is Ka band, L band, Ku band, and L would be what in the 5G terminology would be in what's called FR1, frequency range 1, and Ka is what would be called FR2, frequency range 2. K same for Ku. Okay, and even terrestrial cellular. So we talk about this hybrid network, it's a multi-band, multi-orbit network that is integrated in a seamless manner for the user. Now, is it totally seamless? Not yet. And that's where we are headed towards in 6G. So, but I just wanted to give you a taste that we today, and the last item is for an NB-IoT system between Skylo and Inmarsat. And by the way, now Inmarsat is part of Viasat. So that's a little older press release, but it's really part of the Viasat network, where we have a commercial narrowband IoT. So NB-IoT, that's also part of the 5G standards. That's all now working. That is already here. So where are we heading? So in 6G, we are going to go and truly integrate NTN. In the 5G ecosystem, the NTN is still slightly different. It's integrated, but not completely. In 6G, we expect that it will be integrated in completely and seamlessly with terrestrial networks. Now, we want sustainable, equitable, and safe access to space. Now, what do I mean by safe access to space? As you know, we have many systems, and there are some proliferated LEO constellations with tens of thousands of satellites. Right now, there are a few thousand. There are many plans, approved plans, both internationally. China has, I believe, 2 multi-10,000 satellite constellation. Kuiper, OneWeb. There are many, many satellites that are going to come up, and whether they will all be able to coexist in a seamless, equitable manner is still to be seen. And that is one of the areas that we want to see the 6G ecosystem help us get there, where access to space is sustainable, equitable, and safe. Many countries, for geopolitical reasons, are also launching their own system. Europe has an IRIS² satellite system. The Russians have their own, China. And so how all of these countries with geopolitical needs that are not necessarily aligned with ours will coexist in an ecosystem is still something that remains to be seen. Of course, efficiency of energy, spectrum, economics, these will all matter. It's all good to talk about NB-IoT or NR-NTN, and it's all great to talk about being able to track every little thing, but it has to be done at a price point that is affordable for everyone, okay? And we have to, as a result, as a standards organization in the 6G and in the industry ecosystem, focus on the things that provide real value. And when I say real value, it comes down to the price point, right? So that's where things are really important. Now, first a word on the spec. Now, true NTN and TN, terrestrial networks and non-terrestrial networks, as satellite and cellular as a shorthand, it still came a little later to the 3GPP standard, as I mentioned, not completely seamlessly integrated, but we are still a little different, okay? But, I won't go into this in too much detail, but just to point out that this integration, as we go from 5G to 5G Advanced to 6G, we hope is going to head in a direction that's going to make the networks truly seamless, right? And beyond 5G to 6G Advanced, okay? So what's coming? What's coming is safety and mission-critical services, public warning systems, emergency SOS, disaster roaming, mission-critical, resilient communication. And resilient communications, especially mission-critical communications in a defense sector and so on, really requires multiple technologies to work seamlessly. Okay, so that's one of the big focus of 6G, right? So massive sensor networks are also coming, right? Low cost, simple environmental sensors. There's a lot of concerns about climate change, right? If you think about it, our satellites are one of the few things that can cover the entire world. Have essentially our eyes or our RFIs on the oceans, everything from the oceans warming and so on. We can detect it, but it will require a massive sensor network, again, at price points that make sense. Low data rates, intermittent communication, but necessarily reliable, perhaps asynchronous transmissions, right? And not everything is going to be IP based, right? So it's going to be multiple different forms of communication. I mentioned mobility, or I mentioned scale, and so planet scale mobility. When I say planet scale mobility, you can think about your cars. Your cars are now going to be connected to the network, and with AI and self-driving cars and so on and so forth, the ability to connect all the time is critical. So not just on the ground, but also in the air, advanced air mobility. And it's not just limited to planes. Like today on various commercial aircraft, you can get access, but it's not just limited to your commercial passenger jets, but also things like drones. Shipment by drones could be a reality, in which case, again, we need connectivity. What it means is there is a scale issue, and the network has to be able to handle the volume of data that's going to come with this level of scale, okay? So as far as the air interface is concerned, I'm not going to talk about it a whole lot, but the satellite air interface engineer's mantra is to keep repeating this smaller, faster, lighter, cheaper mantra over and over again, right? And we expect the same will continue for 6G. And again, I don't need to go into it in too much detail in the interest of time, but really we want more power and energy efficient waveforms. We are already considering various schemes within 5G for OCC, orthogonal cover codes, as a way of increasing the capacity on return link and so on. These things are already being discussed in 5G release 19 and so on. And so we expect that movement to keep on going. The idea being satellite connectivity is going to be seamless. So your cell phone's going to be able to connect to it. But you know what? There's going to be a different classes of terminals. Your cell phones may be the smallest, but maybe your car has a higher or a better antenna, and so it has a higher power UE, which is again also something that is being looked at in the standards organization. So more scalar and granular. Like we've already gone to scalable or different numerologies in 5G. We expect that pattern to continue because the range of devices, the capabilities of devices is going to vary all the way from extremely tiny, cheap IoT devices to very capable wideband devices. So from very low band, ultra low band to ultra wideband. This is a range that has to be accommodated, and that's going to be, again, a part of 6G, we believe. Again, scalable, lean, flexible. And again, in the interest of time, I won't necessarily go through all the bullets, but bandwidth granularity is really important. At the end of the day, everything comes down to spectrum. Do we have access to spectrum? If we don't have access to spectrum, none of this works. And the spectrum, especially globally, is not necessarily available in big, large, contiguous chunks. We have a little bunch here. Like, for example, Viasat has L-band spectrum. Probably we have through Inmarsat, we have access to some of the largest L-band spectrum in the world. But it's not necessarily all in contiguous one chunk. There are various chunks of spectrum in various parts of the world. So we need the ability to have better spectrum utilization. And one of the earlier speakers spoke about the CBRS band and how the spectrum sharing is becoming more and more of a mandate from the government. And this we expect will continue. So the standards will have to be able to deal with spectrum which is fragmented. This is a really important aspect of the spectrum. Again, as I said, we are looking at various schemes, CDMA, spectrum with spread spectrum for mass scale asynchronous transmissions, right? So all of these things will come in. But again, the key thing, the one key takeaway is the breadth of devices, the range of devices, the massive scale of data that's going to come in, and the necessary reduction in costs in order to make it accessible globally. Okay. Of course, security is an issue. We are seeing already in Europe, in geopolitical issues, network security, satellite security is now crucial to national security. Maybe it's not just now, it's always been there, but what we are seeing in Europe is how important it is. And this is going to become a paramount driving part of 6G. So physical layer, MAC layer security, encryption, better encryption methods. And the next item is the other side of things where things might get handicapped. Today, all of your cell phones are relying on GPS. Well, GPS or GNSS might be denied or might be not available at all because the use case might include not having GPS at all. So how does the network work when it does not know a GNSS location? So improve network location, determination, validation. These are important things that will be part of 6G. Okay. Again, resilience, interference, intentional or otherwise, and privacy. These are all part of the ecosystem now, but they will get more and more important as we move on. And again, the world events of the last few years has sort of shown how important these things are from national security point of view, and various governments are also getting involved in making sure that this is there in the standards, right? So better forwards and backwards compatibility, that's another really important point. Okay, so can we really coexist with old devices, existing devices? And we really need to go designed for evolution, not revolution, where everything is totally new and the old doesn't talk with the new. So that doesn't really work anymore, if it ever did. But that's an important part of the system, right? So if you look at the network, right? Now, we need novel and improved NTN or non-terrestrial network topologies, right? The space-to-space communication right now is just limited to ISLs or inter-satellite links, right? And even then, those are at a fairly rudimentary level right now. Where we are headed to is true LEO to GEO communications. So you go to a low Earth orbit satellite, go up to a GEO satellite if necessary, and download somewhere else, right? And there are real important use cases for these where a LEO has only visible Earth that it can see that's fairly limited. As a result, if you go up to a LEO and just stay at a LEO, then you have to download your data in areas where you may not feel comfortable from a security point of view. So the ability to go from a LEO to a GEO, and then a GEO, remember, can see 1/3 of the planet, where you're downloading the data to the feeder link at locations that you feel more comfortable about, is a really important criterion. And we really think about it as an integrated network where it's a multi-layer communication. And we're already at that point. We already have multi-band, multi-orbit. Where we are headed to is a truly seamless multi-layered network, which can sort of change its configuration as and when needed. And together with this, you may imagine that in previous generation of satellite system, a particular piece of Earth was illuminated by maybe one satellite with one beam. So there wasn't much of an optimization problem to be done. In modern systems, if location on Earth may be illuminated by multiple satellites or multiple systems, and how do you assign a particular UE to a satellite is now a network optimization problem. So for people in academia, these are the kind of problems that are of very significant value to us, okay? And again, deeper terrestrial network, NTN network integration. I think I've hammered on this point quite a bit more. But as we go back and forth between one to the other, with systems that have very different latencies, right? The terrestrial network has very different latency than a geosynchronous network. Not all traffic is latency sensitive. Your Netflix download is not at all latency sensitive, whereas a video game, which is a in-person shooter game, probably is, right? So the network has to figure out how to divert one type of traffic versus another, all the while in the presence of encryption, right? So as traffic goes more and more encrypted, how that is going to happen is still something that we are keenly looking at, right? So AI, of course, that's the topic for today's meeting. And so how can we do AI? So one of the big things with flexible satellites are satellites that can move their capacity around, is that there's a lot of overhead or significant overhead in channel estimation, maintenance, and so on. And of course, AI is used to minimize that or lower that overhead quite a bit. And some of the other speakers today already talked about that. Data compression, those are more standard ways of doing it. The big thing is, as you have this multi-layered network, how do you route traffic? How do you know to go on path A versus path B? Those are some of the things that I think are going to be the big challenges coming in. So we've talked about the network and the satellite system, but what about the apps and the OS and the stack? And really, some of these things are also changing, right? I mean, things are moving from TCP/IP to QUIC, right? These are becoming much more responsive protocols, and even within Android, right? So now there's already the NTN network access protocols and so on, and not just Android. Of course, Apple has this with their Global Star network, which is also already in operation. So one of the things to keep in mind is, today, of course, I represent Viasat, but the entire satellite industry with many players is moving towards this convergence. So it's not just one, but there's a huge momentum, and NTN is perhaps the most exciting thing in the 5G to 6G transition. Well, of course, I'm biased, but I'll say that anyway. So 6G is probably still a little far away. I mean, release 20, we are not even at release 19, so release 20 is a little bit away. But it's not too soon, especially in academia, to start thinking about these problems and what will be the feature set of the first 6G standard. And as we are moving towards this, we in industry are certainly interested in figuring out what's the art of the possible, and and ensure that the standards will hopefully include that. So that's all I had. Quick talk, but if anyone has questions, I'm happy to take a few. Hopefully, I'm on time. Okay, sorry about that. We're beyond time, but thank you for listening. Always good to be back.